for posterity. So it is being recorded, just FYI. So what I want to talk a bit, I'm going to sort of open things up, I guess. The first thing are some logistics. I'm going to put us into what we call a lecture mode, and that's going to mute everybody's phones through this conferencing system. And what I'd like for the presenters to do, if you're going to be actually presenting, to hit *6 to unmute your phone. And this just makes everything go a little smoother. So you're going to hear some noise right now, just so you know.
All callers are muted and may unmute themselves by pressing *6.
So again, I need for those that are going to be speaking to hit *6 to unmute your phone so that we can hear you. I'm going to keep on talking for now. The second thing in terms of logistics is that we are going to do questions and answers, but from a webinar sort of technology perspective, it's easiest to do this at the end, so that we give all the presenters the right amount of time. So, and the way we're going to do that is through the Q&A functionality of Microsoft Live Meeting. So at the top of your little navigation bar, there should be something there that says Q&A, and you can just type in your question. You can type it in at any time, and I will see it and I will moderate it. But we're going to do the Q&A at the very end. So I think that's it for logistics for this phone call. We have about 100 people signed on right now, which I think is great. We had about 150 people sign up for this webinar series so far. And if you would, if you're a DOT or some sort of, an MPO or some sort of other agency, and you have multiple people in your room sort of listening in together, if you could just send me an email and just let me know how many. We're just trying to keep track of how many people are attending these webinars to see, how great they are. So my email address is mhardy@ashto.org. So that would be great. Second thing, before I go into this sort of next slide, is I do want to thank FHWA for helping to fund these webinar series. It is a joint effort between FHWA and AASHTO. We're kind of providing the technology and trying to help with getting some of the people organized. We also have Spy Pond partners, Yana Park, Perry Lubin, who have a contract to sort of help organize this as well. So this is definitely a overall team effort. And as I said, we are going to be recording this webinar, or all of these webinars, and posting them up to the AASHTO subcommittee on asset management website. That website is TAM.transportation.org, and I just want to once later on this week, I will post this webinar up there onto to our webinar page. We do have recordings of a webinar series that we did last fall, which I think would be valuable, sort of focusing in on the implementation guide, the transportation asset management. Transportation Asset Management Guide to focus on implementation that was published last year. We had a 4-part webinar series on that. Those webinars are available. So if you are a DOT or local DOT, county, state, MPO, transit agency, whatever, I think that might be useful for you. And you can go to again, tam.transportation.org, look for that. The other two things that I want to mention is that we've started here at AASHTO a new asset management video series through our Transportation TV. It's called Asset Management Now. The first 2 episodes are out where I talked to Kirk Steidel, who was the immediate past president of AASHTO, and this month talked with Mike Hancock, who's the Standing Committee on Planning chair here at AASHTO, both talking about asset management within their states. And finally, in April of 2012, we had the 9th National Conference on Asset Management. During that conference, we had a peer exchange, and we recorded that peer exchange, and we've posted up to again, tam.transportation.org, recordings of the presentations that were made during that peer exchange. So, for example, Corey Pope is up there talking about asset management in Utah, Jennifer Brandenburg from North Carolina, Tim Henkel from Minnesota, and a few other ones. I think Scott Ritrath from Colorado. So again, if you want to hear them talk about asset management in their states, another resource for you. So you should see a slide here, slide number 2, the title being FHWA AASHTO Asset Management Webinar Series. This was sort of the brainchild of FHWA and AASHTO. It's a great way to sort of share knowledge about advancing the state of the practice for asset management. And as we all know, within MAP 21, there's a strong or heavy emphasis on asset management, developing risk-based asset management plans. So hopefully this webinar series is sort of a capacity-building effort to help educate the different DOTs out there about asset management and what other states are doing with regard to asset management. So this is the first of a 12-part series. This is going to happen every other month over the next 2 years. So the first 4 have been set. This first one on safety, and then we have 3 other ones, asset management performance, risk-based asset management plans, then GIS and asset management. And we do welcome further topics or ideas that you may have on potential webinar series topics. I got one about extreme weather events and asset management, some interest in that. So if you have ideas, again, send them to me or send them to Steve Gay at FHWA, and we'll, as we compile the next set of 4, we'll take those into account. So that's all I wanted to say to get us started. I will now turn it over to Steve Gay from the Federal Highway Administration.
Hey, thank you, Matt. This is Steve. Just wanted to say that in addition to the AASHTO subcommittee site on asset management, don't hesitate to visit the FHWA asset management website. Just Google FHWA asset management. We have many of the materials that Matt mentioned and others. With the whole idea of sharing information on good practices in the U.S. and abroad. You're all familiar with MAP 21, following up with what Matt said, that each state is required to develop a risk-based asset management plan for the NHS to improve or preserve the condition of the assets and the performance of the system. The asset management plan must address pavements and bridges, but it's recommended or encouraged that it include other physical assets. So on that, I'll say, well, what about safety assets? The discussion and focus of this webinar is on presentations and additional material on the subject of asset management, highway safety assets. There was a peer exchange that was held in Cheyenne, Wyoming, August 2011, sponsored by Federal Highway and AASHTO, and we had some very good presentations. There are some of the key questions that were very relevant then, maybe even more so now, particularly as highway safety is a priority of all state DOTs. Which assets are most critical to maintain safety? Which assets, if they fail, will result in severe safety-related consequences? What level of degradation or deterioration becomes unacceptable as opposed to undesirable? Which assets give the greatest return on investment with regard to safety? And I'm sure you can say, you look at your data analysis of crashes and the physical assets out there, how much analysis really takes place? Next slide. And, I guess in general, the purpose of the webinar and the peer exchange is to share lessons learned and also to present approaches to better incorporate asset management objectives into highway programs, safety programs. And when you do the whole trade-off analysis, safety is an important area that you can't forget in building, one area from another. At this point, I'll pass it on to Yana, and thank you.
Thanks, Matt and Steve, for giving us a good context for this webinar. As you know, we're here today to share lessons learned related to safety and asset management, share ideas and knowledge as well. The terrific set of presentations today will provide their experiences with incorporating asset management objectives and safety programs, and lessons learned in managing safety assets. Next slide. Our webinar is scheduled for 1.5 hours long and will end at 3:30 p.m. Eastern Time, so you can all do your math to get to the end time. We have 4 terrific presentations today. Our first presenter, our first presentation is from Oregon DOT on their asset management efforts related to building capacity and opportunities for safety asset management and their steps towards a vision. Our second presentation will be from Utah DOT. They will share the progresses they've made with their asset management and safety initiatives. And our third presentation will be from North Dakota DOT on their sign inventory and retroreflectivity program. And our final presentation will be from Wyoming DOT, who will share with us their work tying safety information to setting asset priorities. As Matt has mentioned earlier, if you have any questions during this webinar, please write them into the entry screen on the live meeting site that you're all on. And Matt, at the end of all of the presentations, will go through each of the questions in the order that they came in. All right, next slide. So let's start with our first presentation from Oregon DOT. Our presenter today is Steve Linland, who is the Roadway Engineering Manager for the Oregon DOT. He's going to share with us an overview of ODOT's effort towards building a robust asset management program and the progress they've made related to asset management and safety. Steve.
Thank you. This is Steve Linland, and I'm the asset manager of about 6 to 8 different assets. Unfortunately, Laura Whipper, Asset Management Integration Manager, wasn't able to be here today, but she actually prepared this PowerPoint presentation. We started our ODOT journey starting in about 2006. We looked into what other states were doing as far as asset management, and we developed an asset strategic plan. Then in 2006, we also began an asset management pilot project where we went out and actually did some inventories and collected data on various assets. And we learned some very important lessons that helped us out down the road. One of which was basic inventory, that with just a few minor data fields like type, size, location, and first level condition, that you can make a lot of program decisions on just limited information. The other thing we learned was that you collect it once and use it for many applications. We were collecting signs on one stretch of highway, and it just so happened there were 2 or 3 other efforts collecting sign information for either budget purposes or a sign project on the freeway. And so we're trying to coordinate these data collection efforts to minimize them and just do it once and use our enterprise database systems so everybody can have access to that information. The other thing we learned is documentation, so that everybody's collecting the same information, and we'll talk about that more in a little bit. Half-life of data. During the asset management pilot, we were collecting sidewalk information, and there was a prior inventory done in the mid-90s that we had done statewide and had tried to maintain the data by using our contract plan information. Well, we tested one stretch of highway through a small town in Oregon, and our database showed that we should have had 3 miles of sidewalks. Well, when our team went out and actually counted and measured the sidewalks, we found 9.3 miles. And we were just getting ready to go to the legislature with this information because we have a performance measure on sidewalk completion. So we had to stop real quick because the information was so outdated. So we had to go and re-inventory the sidewalks after the pilot was completed. But data maintenance is just really critical. The other thing we've learned is that you can collect the data, but it doesn't do any good if people don't know about it and use it for project decisions or program decisions. So we've developed a FACTSTIP data sharing tool, which we'll talk about later in the presentation. We also have learned that the data allows you to make programs and establish new programs. So, such as the 1R paving program, and that will be also later in the presentation. So, our original plan going into the pilot, or just after the pilot, was we'd maintain the data that we currently have, inventories on bridges, pavements, ITS sites, and we'd begin new inventories on bike ped facilities, sidewalks, bike facilities, ADA ramps, retaining walls, culverts, traffic barriers, wetland mitigation sites, traffic structures, signs, approaches, and unstable slopes, rock fall. Next slide. And I mentioned that documentation is real critical since you have various people going out collecting the data. Some of them can be your DOT staffs. We used a lot of interns. Some asset managers use contractors, some temporary employees. So we developed in this data collection manuals for sign data, roadside barriers, bicycle pedestrian facilities, including ADA ramps and curbs and culverts. So how did we do? Actually, I think we did really well. Right now, we now have available data on tunnels statewide, signs, traffic barriers, sidewalks, ADA ramps, bike facilities, way motion sites, sound barriers, wetland mitigation sites, material sources, and we have partial statewide information on culverts, retaining walls, unstable slopes, and approaches. And we're just beginning some efforts on major traffic structures and stormwater facilities. So we collected all this data and we found out that, one, a lot of people didn't know we had it available. Two, sometimes it just sat on somebody's computer, so it wasn't easily accessible. So if you didn't know that John had the pavement information sitting on his computer, you wouldn't know to call him or email him to get this. So we developed a data sharing tool called the FACTSTIP tool. It has two parts. One part is the visual part, the GIS mapping tool. Here's a screenshot of our latest version of the tool. You can pick various backgrounds. You can use aerial imagery. You can just use a streets background or a topo or a light gray background, depending on what you'd like to view. And then on the left, you pick the various information, thank you, that you would like to show on the screen. The other part of the tool is a geospatial database where you can query information based on highway, mile point, and buffer zone. Since it's actual geospatial database, you put in like a 1 mile buffer, it will also capture intersecting highways. So if you put in Highway 01, you will also get Highway 009 if it happens to intersect within your segment of interest. This is the data we have available. Most of the data is available on both the geospatial database and the GIS mapping tool. There are a few things that are just on the GIS mapping tool. The queryable database also has more data fields that you can view or get information on. The GIS mapping tool is a shorter list typically. We worked with all of our regions to make sure we categorize things in understandable and easy to find groupings. This is actually several screenshots. In the upper center is a list of the features and data that's available in our queryable database. On the right is a screenshot of where you can view the data. If you want to export the data, on the lower left is a screenshot of an exportable Excel file. You can then print that out, load it up to your laptop, take it out in the field. For those inventories that we're doing updated data collection on, you can update the data, and the FactStiff tool has the capability to upload the data, and it automatically sends an email to our asset management section, and then they send it out to the data owners so they can update their data inventories. So, once we have all this data, what do you do with it? Well, the first thing we've done, one of the first things we've done is our traffic barrier inventory. We actually, for the first time, found out what our needs were for traffic barriers, so we worked with FHWA and developed a 1-hour paving program that's a pave mainly program, and it uses a statewide strategic asset management approach to safety features. A tech bulletin was approved and distributed in 2009 establishing this program. Some of the key items of the program is you can't make any existing safety features worse. We inventoried $76 million of non-standard traffic barrier features, and rather than use the normal 3R process to upgrade safety features, we use a statewide strategic approach to replace them. We developed a $6 million safety fund for traffic barrier upgrades. It's going to be approximately a 10-year program, and we should upgrade all of our non-standard barrier features within that 10-year program. We also, since data is essential for strategic planning, we implemented a roadside inventories in conjunction with these projects to maintain the asset inventory. So for the first time, we actually identified all the 11 non-standard features associated with our traffic barriers, and we prioritized them 1 through 11. And we agreed as an agency and working with our federal highway partners that we would upgrade the top 7 of those 11 using that $6 million a year program. And the other bottom 4 features we would upgrade after we finished the statewide upgrading of those 7. Our strategy was to do the interstate system first, move on to the national highway system, and then the non-NHS system. And each of those is about a 3 or 4 year effort, so we decided it didn't make, there wasn't a big need to further prioritize features within those highway systems. So other things we're working on. In 2011, we just completed the ADA ramp inventory, and we identified all the needs, and we actually also did an evaluation of which ones didn't meet current ADA standards. And so we identified approximately $24 to $35 million of statewide ADA ramp needs. We used that to develop a 1-year ADA ramp program. It just got approved 2 months ago. It starts in fiscal year, construction year 16. So we've just developed a steering committee to prioritize how we're going to upgrade those ADA features. We also just recently, 2 months ago, also developed a $6 million culvert program, also starting in 2016 construction year. Our highway leadership team directed us to do culvert inventories on some priority corridor routes, and they gave us 2013 and 2014 to complete those inventories so that we can replace or repair our priority culverts. In 2011, we just recently developed a new asset management strategic plan. It has 4 basic components: a strategies plan, an implementation plan, a communication plan, and a technology strategy. It also has an updated asset list. The prior strategic plan had a short asset list, and it had just priority and non-priority assets identified. Also, Also in 2011, on the upper left, is a rating criteria worksheet. We have an asset management steering committee. They rated all the assets on various categories, safety being one of them, and we prioritized all of our assets 1 through, I think it's about 24 or something like that. And we have 4 different tiers. Safety was a criteria, and in addition to what most people would think of as safety-related features like signals, signs, and traffic barriers, we also consider sidewalks, ADA ramps, and bike facilities, also safety features for those other users of our system. We also agreed to a governance structure for asset management. At the top is our highway leadership team, which develops policies. Below that is an asset management steering committee that develops plans and priorities. And just recently, we've developed an asset data management committee to update and develop new standards for asset and data management. Then we also have what we call a trans-COI committee. That's an ITIS committee that approves systems and new initiatives for IS projects. The heart of this governance structure are 3 main people: our chief highway engineer, our transportation development administrator, and our state maintenance engineer. Some of the things we're working on: mobile GPS applications. We developed one for approaches. Last summer, we developed one for a basic conditions inventory of culverts. We're going to be developing one for signs this spring, and then there's other 1R related inventories that we'll be developing applications on, which include sidewalks, bike facilities, ADA ramps, and bridges. We're doing a QA/QC of our asset inventories. Just last week, actually, we completed a QA/QC of that asset management pilot project. We went back after 5 years and redid an inventory of those highways, and we found that over that 5-year period, there were 16% new features or modified features for sidewalks, bike facilities, ADA ramps, and traffic barriers. And that's probably low of what you'd normally see because of the economic downturn. There was less developer work in our right-of-way, probably fewer local projects on our highway system. So we're looking at that as a way to gauge how our inventories are maintaining their accuracy. We're also beginning some new initiatives on culverts, as I mentioned, and also on approaches. And that data management committee is also developing and updating data standards. Some of the next steps is to plan and implement the culvert inventory. We need to begin next spring if we're going to be successful in completing that culvert inventory. We're also developing enterprise data management systems, data standards, enterprise data storage systems, and integrating data into decisions. Another one of those decisions that was recently done was the ADA $1 million set-aside. And then most importantly, communicate between the different divisions within the highway section. Thank you.
Hi, this is Stan Burns, and I'm here representing the Utah Department of Transportation. With me is Robert Hull. Today's presentation, we're going to talk about data collection, our project that we started about 1.5 years ago. Asset management here at UDOT, I'll give you a little bit of a flavor of it. Safety management, Robert's going to talk about that, and then I'll jump back and talk about future direction. You know, I was very interested in Oregon DOT's presentation on what a good feel they have of their assets other than paving and bridges. And Utah was way behind, and we had no idea where our assets were other than bridge and pavement. So a year and a half ago, we started a unified department effort across the entire department to collect all assets from fence post to fence post. And we had traffic and safety, maintenance, asset management, bridge, the TOC, motor carriers, all joined together in a common effort to collect, as I said, every asset from fence post to fence post that you can see, all geospatially located and providing conditions on some of those assets. The purpose was, you really can't do asset management, you really can't do safety management if you don't know what you have. So we're quite excited about this project, and I'll tell you a little bit more about it in the next couple of slides, but this picture represents the LiDAR and imaging. You can go to the next slide, thank you. So, what is a data collection project? As I said, we started about a year and a half ago, enterprise across the entire state. It's a continuous survey of the entire state highway system. We collect information in both directions. It's about 6,000 centerline miles, and when you do both directions, you do visitor centers, ramps, rest areas, welcome centers, ports of entry, you get about 14,000 driven miles. Scope. As I said, we collect everything. We start with pavement condition. And we've been doing that for many years, but we're continuing that effort where we talk about, we collect rutting, cracking, faulting, environmental cracking, surface areas. We wanted to know exactly how many square yards of pavement we had, whether it was concrete or asphalt, and where it is. And also bridge clearance, enhanced bridge deck analysis. We're collecting cracks to 32nd of an inch. Geometry, we're going to have horizontal, vertical, and cross slope of all those 6,000 centerline miles, 14,000 driven miles. Geolocate all the assets, as I mentioned before, but what it includes is every sign that we have, every signal, all the paint lines, the markings, the intersections, the barrier, guardrail, rumble strips, retaining walls, noise walls, billboards. And I didn't mention how we're doing this. The middle picture is the Velodyne laser. It puts out 1 million points of light per second. And that point cloud that is generated by the LiDAR is responsible for geolocating all of those assets. The reason why we can do this from a cost standpoint is, one is we have a joint effort with everybody in the department sharing the cost. And so we're not creating duplication. 3 different groups within the DOT are not collecting signs, just one. And then a lot of this is becoming automated and semi-automated. The pavement distress is almost all automated. Many of the assets are semi-automated, so the price keeps on coming down. Next slide, please. So the work product. And Matt, you want to step through these? Thank you. The right-of-way digital imaging, we take 200 images per mile. That's every 26.4 feet. 400 in both directions. There's 3 images stitched together. The resolution is 2400 by 3200. We're going to have 5 to 6 terabytes of imaging for the entire state. Along with that, we're going to have a workstation. And all those assets I mentioned in the last slide, you can sort, query, export, do analysis. That's part of the tool that the contractor is providing. And this is by Manley Communication. It's the winning contractor on this. Next map. And then to make this asset extraction economically feasible and very accurate is mobile LiDAR. And that's a picture of a section of roadway. You can see the striping. You can see the railroad crossing symbols. Next slide, please, Matt. I mentioned project funding and project cost, and I mentioned the reason why we can do this, why we can collect every single asset, is because we have a joint effort between primarily planning, central maintenance, and traffic and safety. You know, this is a little bit like, I understand that the former Soviet Union didn't have a very good telephone system. And so now they have a great one with cell phones. They just skip the hardwired part. And that's sort of the way it was at UDOT. We had no idea where our assets were, our inventory was. So luckily, the technology is ready for us now that we're ready. The price is quite high, as you can see. It's $2.5 million. Next slide, please. Now, why do we collect all this data? And I'm just going to show you two slides in succession. And this is our statewide pavement management. Next, Matt. So what we're representing here is the condition. Green, yellow, red. Good, fair, poor. And it's historical data, and it's also forecasting trends, specific budgets and projects. And then we have thresholds, upper and lower thresholds. So what we're able to do with this slide is we're able to predict the future. If we have $200 million, this is where we're going to spend it. These are the projects, and this is what we expect the condition to be. So instead of reinventing the wheel for all those other assets, we're going to replicate this exact same model that we use very successfully here at UDOT on pavement for our other assets. Next slide, please, Matt. And so we have developed a statewide bridge management system, and I hope the graph looks similar because it's the same type of graph. It's showing historically what our bridges have been like, and it's showing if we spent $20 million a year for preservation. This is what we expect our bridges to be in the years 2013 to 2014. We have a target. We have a good, fair, poor. And so our model now, we can predict the future, recommend projects, and stay within our targets. Next slide, please.
This is Robert Holt. I'm the Director of Traffic and Safety for UDOT. I'm going to go through next several slides here just to talk specifically about the safety component of our effort here. And as you can imagine, it really started off as the basis of looking at MIRE, the Model Inventory of Roadway Elements, and what's critical to safety management. When this first came out, there were recommended 202 elements. Further refinement from FHWA, that's represented by the next bullet point, really focused down onto 38 fundamental data elements. Now, the interesting thing about this is we had already started down this path, and as Sam has mentioned, that we were doing it sort of in the very old technology version, and so we were moving that direction when we had the opportunity to collaborate on this data collection process. The 38 elements really are now kind of our guidance moving forward. As an example, and what you've heard from Oregon is an example of one of those efforts that we're going to be focused in on, and that's statewide sign management. The real critical element for us is that we don't have any information on our assets from a signing standpoint. We've over the last decade or so, we've built some fairly large highway projects here in the state. And the problem is that all of those signs are going to come due in terms of the life cycle, and we don't actually have a program to fund this for the future, so we need this information to develop that long-term program. Next slide, please. Our next, but where we really wanted to talk about was the safety management system, and how this project, data collection project, really is going to help us marry our crash data, the roadway geometry, and the safety assets, and bringing all of those together into one location, one opportunity for us to do the analysis on that. This just really continues on with the efforts that we've had so far. We're working with Esri. We've worked with the AAA Foundation for Traffic Safety and the U.S. RAP program that they sponsored, and us as a partnership. We're geolocating all of the data and doing an analysis statewide by corridor and by spot location to help us prioritize the limited funding that we have. And what you see here is a couple of examples of our risk maps that are based on the U.S. RAP protocols. And this is information that all of our, throughout the state, our staff uses to develop safety projects. Next slide. With that, I'm going to turn the time back over to Stan.
This is very analogous to what Oregon showed you just recently. We have a geospatial database where we can add any of our features that we've collected and show them, we call this a straight line diagram. You can show it here I'm just showing you ADT, pavement condition, safety index, the location, and the mile posting. That's fine. Next slide, Matt. So it's very similar to what Oregon showed you. It's interesting. We didn't collaborate, but it would have been interesting to compare notes as we were building. Looking forward, as Robert said, we're going to develop a sign management system. We're developing a culvert management system, enhancing our safety management system. And one of the big and exciting things about this data collection project is because we're collecting every single feature you can see from milepost to milepost, geospatially locating all, we're going to be able to build all these management systems. And this might be a model for MAP 21. It might be a model for other DOTs. So we've talked to Esri, Oracle, Bentley, Manly, Dayton, Agile Assets, Virtual Geomatic, AAA, Utah State, and we're forming collaborative relationships with all of those. And we're building prototypes on safety, design, integration, and asset analysis. But the ultimate goal of asset management, safety management, is to answer this question. We're building all these silos. You've heard Robert talk about signs and safety. You heard me talk about pavement, bridge. I just mentioned culverts. But how much do we put into each one of those buckets? So we are still silo-driven at this point, and we are not crossing those boundaries because, quite frankly, we don't know how to answer that question. I do know that there's an NCHRP study going on right now, OA-91, that it's going to try to look at this issue and try to resolve it for us. They're going to ask for state volunteers. They're going to develop a prototype for resource allocation. And maybe this can answer the ultimate question that we here have at Utah DOT is, how much do we end up spending? How much do we end up putting into each one of those buckets? What are the outcomes? What happens to signs if we spend X dollars on it as opposed to pavement? And so that's the end of our presentation. Thank you much. And we'll wait another half an hour for questions, but there's Robert's email and my email. Thank you.
Thank you, Stan and Robert. And all of these slides will be posted, as Matt said, on the ASHTO Asset Management website. So you'll have that information to download after the webinar. So our next presenter is Scott Sanhofsky, who's the Planning and Asset Management Division Engineer from the North Dakota DOT. He will share with us the progress they've made in their sign management program.
Thank you, Yana. My contact information is here on this slide, and will also show up for you on the last slide of my presentation if you want to get a hold of me in the future. What I'm going to talk a little bit about today is our Roadway Information Management System, or RIMS, and the first thing that you will notice is that it's a very arcane-looking piece of software. It was originally developed back in the 80s, and it is a mainframe system. But then I'm going to show you the breadth of information that covers, and then I'll get into the depth of information that it contains when I get to the sign portion of RIMS. And then I'll show you how that information is ported to a very modern system, very similar to the previous two presentations that you just saw. And then I'll finish up by touching on the maintaining minimum retroreflectivity based on the MUTCD requirements and our current status of sign management implementation within North Dakota. So, as I said, this is obviously a very archaic piece of software, but my predecessors back in the 1980s had the extreme foresight to put all of our asset information into a single program and a single package. And this is the main menu screen from RIM, so it gives you an idea of how wide an area of information is actually covered in RIMS. It has everything from our project scheduling to project development milestone activities, construction history on the various segments of our highways, what those highway segments contain as far as the materials, an inventory of the various assets that we have out there. And but like I said, it's extremely powerful, beneficial piece of software in that everything is interconnected. And as I talk to colleagues around the country, I find out just how unique this is and how great of a tool it is for us. And we've tried a couple of different times to replace this software. It's a difficult thing to replace because of what it does contain. But we are attempting to replace it yet again because mainframe applications are just extremely difficult to maintain. What you're now looking at is the sign-in information that we have within RIMS. And like I said, it's an extremely deep piece of software in that obviously this screen just looks like a jumble of text, but let me break it down just a little bit for you. The white portions of the text on this screen you can think of as kind of like the section breaks. So up at the top, we have the assembly information, so, location of the sign, the highway number that it's on, the reference point, all of that kind of stuff, the distance from the center line, the height of that sign, the post size, and even the type of post that it's mounted on and the number of posts. Moving down into the next section, we're looking at the sign information itself. We have the MUTCD sign number. We know that this is a stop sign. We have the size of the sign, the size of the legend text, the type of material that the sign itself is made out of. So in this case, that back material 2 is a flat aluminum sign. We have the direction that sign is facing, and then we have the information about the sheeting material itself. So high-intensity sheeting on this one with a white legend and a red background. I mean, surprise, surprise, stop sign, right? But anyway, virtually everything you'd want to know about the physical characteristics of this particular sign. But then the interesting piece comes, if you back up just one second, Matt, I'm sorry. The maintenance activities are the next elements that are recorded in here. First, moving over to the right-hand element down at the bottom, that's basically the initial installation date. So what that tells me is that coupled with the next one over, very little has happened to this sign, or at least nothing's been recorded as having occurred to this sign since it was originally installed in November of 2001. But the left-hand code, what that tells us is that sign was inspected on September 7th of 2012, and that it did not pass inspection. So this sign then is scheduled for replacement as a result of not passing inspection. Everything above these maintenance activities is incorporated into the next application. Very similar to the other two states, a GIS-enabled piece of software. We call this our online roadway analysis and mapping portal, or OnRamp. And this is intended to be almost dummy-proof, if you will. It's a very simple piece of software from a user perspective with a tremendous amount of development time by some really talented GIS people within our department. It's very similar to Google Earth, if you will, except there's a lot more information here. Very similar to the other states. Everything, or not everything, but the vast majority of things that we have in RIMS are accessible through OnRamp. We are currently working to get that maintenance information that I talked about for these signs into OnRamp. What we have done, or what our GIS people did, was develop lookup tables that allow people to, with a single click of a button, access that RIMS data that I just showed you. Obviously, this is a much more user-friendly way of accessing that data. And what we have through OnRamp, we've got light standards, culverts, pavement condition information, we've got some bridge information, we've got guardrail, virtually all of the assets that you may want to know about within our right-of-way. But in addition to that, we drive our entire system with a pavement management van, similar to what UDOT just talked about. But we do the entire system every year. Our undivided highways are driven one direction each year. Our divided highways are driven both directions each year. So this lower panel that you see at the bottom that says Identify Panel contains all of the sign information for the sign that you see in the picture above it. And those are two different elements of OnRamp, but it allows a person to access all of the data, the physical characteristics of a sign, and then go and look at the last image that we took of that sign. So the oldest images that we would have on this system would be about 2 years old, because for our undivided highways, as I said, we drive each direction, or drive one direction each year. So that combination of being able to look at that sign as it existed, in connection with having all of the other information about that sign is extremely powerful. And as long as you have a computer inside the firewall of our network, you can access OnRamp. And it's used extensively by our personnel within the department for design and planning activities. Next slide, please, Matt. As most of you are well aware, the 2009 edition of the MUTCD required agencies to implement a retroreflectivity maintenance program. And that was originally supposed to be implemented by January of 2012, but a later revision moved that to June of 2014. And also reduced the scope of the requirement for which signs need to be incorporated. And we now have to have the regulatory and warning signs done by June of 2014. We as a department decided that that wasn't soon enough and regulatory and warning signs weren't enough, so we began implementing this year. Next slide, please, Matt. For department-wide activities in North Dakota, what we typically do is prepare decision documents. And so in December of 2010, our Deputy Director for Engineering signed a decision document that said that we would begin doing inspections on our signs for retroreflectivity in 2012, and we would program our first projects to address any non-compliant signs beginning in 2013. Well, for our department, we have approximately 64,000 signs in our inventory, and we estimated that about 10% of those each year would be non-compliant for retroreflectivity, and that allowed us then to program our first project for 2013 and get the ball rolling for those activities. But the question, of course, is how do we inspect 65,000 signs? Next slide, please, Matt. The MUTCD has multiple options for the inspection method. What we chose to do in North Dakota was use what's called the visual nighttime inspection. And basically what occurs there is that trained inspectors go out and inspect all of the signs on the system every year. And they inspect those from a moving vehicle at normal operating speeds. Next slide, please, Matt. And the way we're doing that is our maintenance division purchased a retroreflectometer and provided that to our materials and research division. We then used that to establish control signs. Those control signs are stored at Materials and Research, but at the beginning of each inspection season, they send those out to our inspectors, who then view those signs every day before they go out and do their inspections. It's not just a single viewing at the beginning of the season. It's every day when they go out to do their inspections, they view those signs to essentially recalibrate their eye, if you will. Those signs then are sent back to our Materials and Research Division at the end of each season to be checked to make sure that they still meet the retroreflectivity requirements. And basically, those signs are set up so that they're either right at the limit or slightly above the required limits. And then via using highway speeds, our inspectors are able to make decent headway on inspecting those signs. The current status of where we sit right now is that 5 out of our 8 districts have completed their surveys for this year. Of the just over 40,000 signs that have been inspected, about 4,900 of those were found to be non-compliant for retroreflectivity. So that averages out to about 12%. Obviously, that's a little bit over the 10% that we had estimated, but it's well within tolerance. And we're not sure how that's going to continue out into the future. We'll see. We haven't decided the full extent of what we will do with sign management going into the future, if we will simply continue to replace non-compliant signs, if that is determined to be the most cost-effective, or if we are going to do something more along what Utah just talked about and actually model the sign deterioration. But in addition to programming projects, our maintenance forces actually will replace signs, the warning and regulatory signs as well, even ahead of the projects, because our basic thought is that those signs are important enough that they need to be addressed as quickly as we reasonably can. So that's okay, Matt, go ahead. As I indicated a little bit ago, unfortunately, OnRamp at this point in time does not have the maintenance code information in it. But what we can do out of our RIM system is provide a report that looks like this. It basically gives all of the non-compliant signs, and our designers then, of course, use that to design the projects that they need to do, and our sign shop personnel use this to determine which regulatory and warning signs they need to replace even more quickly than that. As I said, we are working to get this information into OnRamp. It's just a matter of preparing an adjustment to a lookup table. Next slide, please, Matt. With that, I will turn this back to Kiana, but here's my contact information again. I appreciate your time and your attention. Thank you.
Thanks, Scott. Our next speaker is Martin Kidner, who's the Wyoming DOT State Planning Engineer. Sitting with him is Joe McCarty of JDI Consulting, who has supported Wyoming DOT Safety and Asset Management Initiatives and is available to answer questions after the presentation. Martin is going to finish our webinar today by discussing how asset priorities are determined using better safety information. Martin.
Thank you very much. So really what everyone should have heard today, they put me on last to try to wrap this up. Obviously we're only concentrating on the infrastructure aspect of the safety. We all know that, the biggest contributor out there is human behavior. But in order to reduce fatalities and serious injuries, all the major parts must contribute: the behavior, the vehicle characteristics, and roadway design. The examples that we heard today are great for laying out the data and infrastructure and how we can tie it together. And so let me give you an example of what Wyoming is looking at. With the critical first step is following the HSM the philosophy there is that you just can't make things completely safe. So we are trying to concentrate on reducing the crashes. The caveat is, crash reduction is the number of, or severity of the crash, is not purely, is this safe or is this not. So this is often, on the type of the crash, so it is very data and calculation heavy on that. And I also wanted to just put in a plug there, Oregon's example of how to set priorities on their guardrail is great. So, one of the big things that I really wanted to stress at this is, getting this information out there in the hands of the decision makers well ahead of the project selection process. That's really one of the main things that we're trying to do, so that safety is not one of the add-ons that happens later on in the project stream. Safety decisions come from many sources, obviously. Network Safety Index, which Wyoming uses, compares the like types of roads into quartiles and hotspots, so that that the particular segment of road, whether it's in the top 25% of the accident-producing areas within the last 5 years of worth of crashes there. Then from that, we developed, really when we talk about safety projects in Wyoming, we really have three types. We have the systemic, such as, trying to get rumble strips on all the roads that we can. Some of the standalone things, such as hotspot corrections, like if we had an intersection that needed a turn lane or something like that. And then the third branch is when we do them in conjunction with other construction. A complicating factor with this, when you talk about safety, being tied on to other projects, is that, and we'll take the Oregon's example again of the guardrail, is that if you're doing something out there like making the guardrail lower by putting a overlay onto it, that it may actually move how your ranking system is on those guardrails. So we need to be aware of that. These all contribute to the identification of locations and a template of what we're trying to get fixed. And where I really tried to document that out at is in our strategic highway safety plan. The critical thing that I really stomped the floor on the strategic highway safety plan that all the states have is, really that this is, when I deal with this as a planner, it really turns into, one of those proverbial onion kind of things where you have to start asking yourselves, what types of crashes are we really going after? And so, for example, the types of crashes in Wyoming that we're going after is the run off the road, the curves, and the intersection. What are the overrepresentation factors that are out there, like, the young drivers, the speeding, the weather, and what are the infrastructure items that may contribute or help in order to decrease these crashes? So, years ago, Wyoming spent a lot of effort in trying to make things safe, in everything that we were doing. Well, now we're trying to change our focus a little bit to spending on the items that we really think is going to make an impact on the number of fatalities and serious injuries. So let's go and talk about a specific way that we went through that kind of ties in these people, what everybody else has talked about with the themes of what's documented in our strategic highway safety plan. And this is an example of what Wyoming did for the curves. And so, basically Wyoming has about 8,000 curves in the state, but when you look at the Pareto chart that you have there, that we definitely had 300 that were at least 10 times the average of the crashes that happened on the curves out there. And so, that really was able to get our people to start zeroing in rather than just trying to fix everything whenever you touch a project there. So, out of these 300 curves that we looked at, we also tied it in with the other things that we're gathering. Utah talked about the cross slope and stuff. Well, that gives you your super elevation, so you got the radius. Utah will have the shoulder width. We had that from other places. And so, really what it did is that it was able, from a data standpoint, to also be able to tell us on those curves that it wasn't just the radius or the shoulder width that was causing the crashes. It was other things that were out there, and so that gave us a focus on it. So when we looked at the remedies that we have out there, when we looked at those first 300, and we got our traffic experts sitting down, and of course, in a room without going out there and looking at the 300, is that they were just started off with this huge number of, well, these are all the things that we could do, but, after some prodding, they kind of narrowed it down and saying, these are the 24 things that we really think that we could go after at first. And then really what happened is that they went out there and looked at a sizable remedies that apply to nearly all cases. Well, now we're getting down to, where you can almost build a decision tree on shoulder width or on if there's a guardrail existing there that these other inventory items take care of. When you get Utah's inventory done for a guardrail, you can start comparing that with these crash areas. So, some examples of what they're coming up with: flashing beacons, chevrons, rumble strips, painting of the guardrail, ITS solutions. Those things all were tying in there. And this gave me, the big advantage of a planner as an asset manager. It gave me in the consistency of the recommendations, and it also allowed me to predict some outcomes of what I was expecting to have out there. So, on the next slide there, you see that I'm, I call it benefit to cost convergence, but really what it is I need a consistent way to determine which projects have the greatest value. And because that's really what we should be concentrating on in order to reduce the fatalities and serious injuries out there on the road. The process that we went through with the curves there showed that we could actually come up with a limited number of remedies that we could propose, that we would normally propose on the average, and then those that we could also predict an average cost and an expected result. And from that I could come up with a prioritization of projects that could be rank ordered against each other. And that's what would give me the stack of the prioritized safety projects that would be, basically the 1 through 100 or something like that as a starting point. So how do I tie that in with my planning that I do? Wyoming is using a process where we try to look at the entire corridor out there. And so you see in there, that we have the strategic plan, which includes that we'll build safe and efficient highway systems, long-range plan that shows how we're going to be spending our money, the corridor vision, what an entire route should look like, and then the corridor plans, and that's what we're going to talk about here just for a minute. That on that overall corridor, I want to be able to answer the question to the decision makers of, within that corridor, what are the biggest safety projects that we really should be concentrating on in order to get the biggest return on our investment out there. And so, looking at it as an overall corridor, defining what the gaps are and so forth that are out there, coming up with a solution set, and then finally, coming up with a recommended list of projects for that corridor. But I want to pause here just for a minute and stress to everybody out there, this, we are not, using the computer to drive the decision making on, thou shalt do this project next, but rather, this keys us off on going out and looking at these safety remedies, and then the traffic professionals out there can actually make the determination of what the best areas are. But this should give them a big leg up on, here is an area that has the highest potential for an engineering solution to correct the problems out there. So, so far I think that it's really changing how Wyoming is starting to look at these projects. So in summary from Wyoming is that, that it goes back to, I want to really stress the strategic highway safety plan, where we get that multiple discipline team in to build this plan, and it starts to focus on what types of crashes we could be concentrating on to prevent. And then from there, our experience in Wyoming is that we can come up with a recommended set of treatments, that solves about 80% of the problems that are out there. And that gives us some of this infrastructure upgrades and installations that could help. Then setting the costs, and such as shoulder widening per mile, and the cost crash modification factor, such as 1.15 for a rumble strip addition, allows us to come up with a prioritized safety treatment list. But it all still comes down to the point that, that shows that it's points where a professional should go out there and look, but it gives you a list of the greatest potential areas to reduce crashes. So with that, I'll turn it back over to Matt, and he can lead us off into some finishing things and lead us into questions and answers. So thank you.
Thanks, Martin. So this is Matt Hardy again. Now's the opportunity to ask your questions. If you have any questions, I haven't gotten any so far. If you have any questions, please type them in. Give you a couple minutes to sort of start typing those in. Just to remind everybody that you can go to the both FHWA's asset management website for more resources. You can also go to the subcommittee, the AASHTO subcommittee on asset management's website, tam.transportation.org, where you can get a bunch of videos and other resources. I also want to plug the AASHTO Transportation Asset Management Guide, a focus on implementation. That is a document available for you. And there's also a book club that is starting. Katie Zimmerman, who's leading an effort funded by FHWA called the Transportation Asset Management Expert Task Group. They're starting a monthly sort of book club. More information is available on either FHWA or AASHTO's website on how to sign up for that. But basically, walking you through the implementation guide. I have a few questions here. The first one is from Ahmad, I think Ahmad from Mississippi, if it's the same one. He asked, what are some of the challenges that the presenters encountered and continue to encounter in developing and implementing an asset management program? So I'm not sure if one of them, Martin, would you want to sort of take a first stab at that one?
Yeah, I just had to get my line off mute. Good.
Then for Wyoming, the biggest problem still is that it just does take time to get our data lined up. When we started off, that I knew I had data. We had a lot of data. We had some great pavement data and so forth. We had a good system, but the biggest thing that, as I used, especially with the crashes and so forth, is when you start trying to say, I'm trying to line up this data in order for my infrastructure to determine the best life cycle cost, is how much of that was not really compatible out there, where I couldn't get it. It existed on somebody's machine, and it wasn't an enterprise level data. So getting my data cleaned up and put into a place where I can use it actually was one of my biggest holdups for items other than the things that we've all been concentrating on in the states, which is bridge and pavements. Most states have a pretty robust system on that. But as far as getting out there to some of these other items, such as safety, that our biggest holdup actually was, I used the term of peeling back the onion. As soon as you start talking about a crash, you want to know what the shoulder widths are. As soon as you know the shoulder width, you want to know what the side slope is. As soon as you know the side slope, you want to know the clear zone. And it just goes on and on with the very data intensive from a safety standpoint. When you start trying to add up, how do all these infrastructure items that we have in asset management work with our safety?
Anybody else want to add to that? Hearing none, I'll go to the next one from, somebody said.
Oh, sorry. This is Steve from Oregon DOT. The two biggest challenges probably are finding resources for our culvert and our approach inventories. Those are pretty expensive efforts. Also, in data maintenance, I mentioned that in the presentation. We collected all that information. Now we got to maintain it so it's accurate, so people will trust it and use it.
Great. The next one, so I have about 8 questions here, starting with PennDOT, who has one directed towards Scott. Has your projections to replace your mainframe rims been cost prohibitive? Could you share a rough estimate to update? And then it goes on to say, it is impressive on how you have incorporated into the GIS format. Also, are you experiencing limitations or adding additional fields in rims?
Yeah, it is very costly to replace rims, and the biggest issue is finding something that can integrate all of the information. But really the biggest challenge that we're having in replacing it is that last piece that I mentioned, is finding something that can integrate all of the information that we have in rims. And as I mentioned, many of our colleagues around the country are finding that their data is very siloed. Well, we don't have that problem, but we have the opposite problem in that now that we're trying to replace that software, keeping it from becoming siloed is a huge challenge for us asset managers, because the IT folks look at this and say this mainframe application that we have is extremely expensive to maintain, but we don't have something that can replace it all, so let's replace this little piece of it. And as asset managers are saying, whoa, wait a minute, don't do that, because if you do that, then all of a sudden that piece of information won't talk to the rest of it that we have. So that's been our biggest challenge in replacing RIMs. Right now, we're talking about potentially doing another in-house application. We would much prefer to buy some off-the-shelf piece of software, but an in-house application, we're talking, I think the last estimate that I saw was $800,000, and our IT folks were saying that that's probably a factor of 10 off. So, yes, it's expensive.
Next question is from Ashante Hastings. I think you're from Delaware, if I remember correctly. Culverts were mentioned several times. I forget who mentioned it within the presentations, but asking, are you referring to storm drains or small crossroad pipes when you talk about culverts?
Well, from Oregon DOT, the culverts are from minimum of 18 inches up to 20 feet.
Okay. Next one.
This is Scott in North Dakota. The culvert information that we've maintained has typically been centerline culverts, so the culverts across the main line of the road. We're working to get our approach pipes incorporated as well, but like the gentleman just said, ours are up to 20 feet, but it can be down as small as 18 inches.
Okay. Next question is from Carolyn Morehouse. How is the FHWA, and this is directed towards any of the four presenters, how is the FHWA travel inventory and highway performance management system incorporated into TAM? Or if anybody's doing that. Hearing nobody want to answer that one, I'll make a note of that one and try to do some follow-up with that after the webinar. The next one is from Carrie Smith. I think it's directed towards Utah DOT, Stan, so I hope you're still on the line there, Stan. What additional cost beyond the initial $2.5 million has Utah DOT encountered with their asset inventory collection?
This is Robert. Stan actually had to step away. At this moment, that's the cost that we have incurred. We have not moved beyond that dollar amount at this point in time. Now, as we get the data back, as was mentioned, we're just in the data collection process, and we're starting to get that information back. So once we start getting it and do some of the analysis, it probably will give us a better feel of additional costs.
Great. So I guess Carrie could actually follow up with, the Utah DOT people to get more information as more data becomes available on the costs. Next one is from Nick Artemovich, and it has to do with RFID tags. Is anyone using barcodes or RFID tags to facilitate data collection or on signs or roadside safety hardware? So the use of RFID tags.
Matt, this is Scott in North Dakota. We're not currently using RFID tags, but we have had a project with one of our universities here in the state to test some applications along those lines. We have not implemented any of them yet. That was done at North Dakota State University.
Okay. Has anybody else, not just limited to RFID tags, but some of the other, like two-dimensional tags or barcodes, or I think these are using barcodes, but any other non-barcode labels? Okay. Next one is from, we have two more. First one's from Pat Morin. How are some of the states updating assets as they are replaced or new assets are installed?
Matt, this is Scott in North Dakota. That's actually been one of our big challenges, is getting consistency in updating that information. We do it in a two-step process here, basically off of the as-recorded drawings, and then we do some spot checks on it. But we do that in two different places, either out in the districts or here in the central office. For the stuff that we consider to be the most critical information, we've centralized that update process. For the other items where we maybe don't have condition information, but we're just maintaining inventory information, we've done that out in the districts, again, basically as an off-construction season activity. Is it the optimum way to do it? Probably not, but it's the one that our resources will sustain.
Steve, Robert, or Martin, did you want to add to that at all?
Yeah, this is Steve from Oregon. It varies by the asset. We also do some as-constructed contract plans to update the information. We also just re-inventory periodically when it deteriorates to a certain point. And there's also, we've just begun a recent effort to re-inventory our traffic barriers.
Great.
This is Robert. We just pretty much following exactly what was just said. That's sort of our process too with all of our inventory items.
And this is Martin. I just wanted to put a plug in. Oregon and Washington both have good examples of when they determined what the priority of their data gathering. They also, kind of touched on, how often it needs to be upgraded. So, I think that's a critical step when you first set out your data compliance is a recognition that you need to figure out how often. My example is that, that we've got approaches. We're trying to get our approach data. We've got an approach database for all the accesses coming onto the highways as part of our safety features that are out there. But it's not something that we'll go out there and do. We do it by the permits that are coming in. So that's one that, after this initial push where, we send everybody out to gather all of these inventory items, our hope is that it actually gets updated simply by the licenses and tying the license to our database.
Steve here again for Oregon. We also, the fact tip tool in the presentation, the exported Excel files are used to update certain assets in conjunction with those 1R project roadside inventories.
Great, thanks. So we have two more questions here, and then we'll have to cut it off. Next one's from Connecticut DOT, directed for you, Steve. How did ODOT or Oregon DOT develop the fax tip in-house, or did a consultant? And if it was a consultant, do you remember who and the approximate cost? Or if it was done in-house, I guess, is how much time or effort did that require, or expertise?
It was initially developed in-house several years ago, and then it was significantly enhanced by a contractor. I don't recall the current total, but the cost, I believe, is in the neighborhood of $600,000.
So here's a follow-on question for me, the moderator's prerogative. Is it purely sort of Excel driven, or is there a database back into that Excel, Excel is sort of the face for, or the user interface?
The Excel files are just the exported information from the geospatial database, and I believe it's a sequential database, but I would have to ask our IS people first.
Okay.
That's just the user, the Excel file is just the user interface.
Okay. Kentucky for the sign management question on the RFID or tags using barcodes. And then the last last question here from Garen Burbank. How important is it to know, that this is to any of the 4 presenters, how important is it to know date and time of when signs, bridges, or other assets are installed when collecting asset data?
This is Robert. I'm going to speak strictly from the sign management perspective. I think it's going to be very important that we do have the manufacturer installation date. For us, anyway, in terms of doing future projections, we have some ideas of what the deterioration curves are of these items, and that will help us project out what our future needs are going to be. So it's always helpful to have that starting point.
Scott, Martin, or Steve, you want to add to that?
This is Scott. Basically, my answer is pretty similar. The installation date, I would say, is extremely important, but I think it depends on your business processes, to be honest. Our business process right now is really an age-based projection of when we're going to need to replace signs and how often we need to replace them. So because of that, that original installation date is vital for us.
Okay.
And this is Martin. Obviously the age is one of the first critical things, because you can do more than just, it gives you indications like some of the ones, and one of mine is that the snow fences that we have out in Wyoming to try to improve the visibility of the of driving while you're in a blizzard there. That those things, that having an age of those kind of things actually helps us on determining how long we think it's going to last, because design changes happen over time. But it also actually, while it helps with the budget on our signs, what we actually found was other things like how much snow that we actually throw off of our snow plows that are hitting the signs is actually the biggest thing that's creating a variance on the length of the age of these signs. And so it really kind of, in some cases, gets kind of a little bit squirrely there about, while a date on the inventory helps you determine what you need to be replacing when, it still a lot of times is not the only factor that you've got to play into that, is what we're finding on a lot of the safety inventories.
Great, thanks. I'm gonna cut off the Q&A there now, because it's almost 3:30, and I want to turn it back over to either Steve or Jana. Just one last comment. If you want to get a copy of the presentations, or if you want to listen to the recording of this webinar, we're going to be posting them to the Subcommittee on Asset Management website, tam.transportation.org. There's a link on the left-hand side called Webinars. Click on that, and you'll find it. Not the prettiest of websites, but I think it has a lot of good information, which is at some point the most critical aspect. So there were a couple other questions that came in late. I would encourage those people to sort of ask the presenters specifically your question through email. And now I can't remember if I'm turning it over to Jana or to Steve Gay to sort of.
You're turning it over to me, Matt.
Okay.
Could you show the last slide?
Oops.
Yep. Yes, so thank you, everyone. Thank you to all of our presenters who did a terrific job. We did take notes on the questions and answers, so that will be posted on the webinar site as well. And to the degree that any of the speakers can further enhance any of their answers, they're welcome to do that as well. So this concludes our Asset Management and Safety webinar. Our next one is on January 9th. January 9th at 2 p.m. It's a Wednesday. They're always going to be on Wednesdays at 2 p.m. Eastern Time. And it will be on asset management and performance management. And then the one following that will be asset management business models and barriers to implementation. And that will be on March 13th. And our final one will be on March 8th on asset management and risk management. The final of the first four, and then we'll continue again every 2 months. But and we'll announce as the next ones get decided on, we'll let you know at the webinars and on the AASHTO website that Matt just told you. Thank you and goodbye.